welcome to application 2A-7. Our learning target is that I can solve and graph inequalities on the number line. Now, if you're looking at those first 8 problems, what you're going to see is problems similar to 1-5 from our first unit. These are going to be translation problems. The reason that we're going back and revisiting this is that it can be very confusing sometimes to figure out when something is talking about subtraction and when it's talking about the actual inequality sign less than. And it also can be confusing sometimes with the greater than telling whether it is addition or a greater than symbol. So we're not going to really work through those problems, but what I am going to do is give you some hints on some of these tricky problems. What I would recommend is jotting these down on the back of your application sheet. That way you can have these as reference as you're working through and trying to figure out, okay, is this a subtraction problem or is this an inequality problem? So you will have a mix of some that are inequalities and some that are not inequalities on this application. Alright, so just going over some tricky things, and this will also go over a little bit of the confusion that we were having on 1-5 with which number is supposed to go first. Alright, so let's just jump in and look at some of these examples. So we'll start off simple. 5 minus x. That's pretty simple. When we write it, we're going to have 5 minus x. Now, this is where it starts getting a little confusing. We're throwing in some words. If it's just less, 5 less x, alright, we're going to end up with 5 minus x. Alright? Just because it says less doesn't mean it's going to be a less than symbol. Alright? The difference of 5 and x, even though that and is there, we are going to defer to the difference symbol, which is going to tell us subtraction, not addition. It wants the difference between 5 and x. Alright, and the next one, 5 is decreased by x. We're taking 5. 5 is the number being decreased, and we're decreasing it by x. So on all those, it would be the 5 first, and then the x. Now, this is where it really gets tricky. If we have 5 less than x, alright, we want 5 less than x. So x is our bigger number. We want 5 less than that. That's why x comes before the 5 here. On our next one, 5 subtracted from x. That again tells us that we're taking away from x, so that needs to be our first number, and then we're subtracting the 5. Now, the key thing in these inequalities for most of them is going to be the simple little verb is. So if 5 is less than x, alright, we're not saying 5 less than, we're saying 5 is less than, we are going to have the inequality symbol less than. Alright, couple other tricky ones that we want to take a look at. Fewer than. 8 fewer than w would be w minus 8. Alright, more than. Just because you see more than doesn't mean it's necessarily going to be a greater than symbol. In this case, we want 2 more than y. So we're going to do y, and to show 2 more of that, we add 2. At most, if Pam can spend at most $200, that means she could spend above she could spend equal to $200, or she can spend less than $200. So she could spend $150, $175, $199, $200, but once she crosses that $200 mark, it's not going to work anymore. So we're going to have P is less than or equal to $200. Alright, at least. If Dad wants to earn at least $450, then we need to be at $450 or above. So we would want a greater than or equal to symbol. So those should help you out. Look back at your notes from 1-5 as well. Those will help you out as well. Remember, we've told you guys to hold on to your packets. Don't throw anything out. You'll need them later in the year when we're studying for the milestone. And you'll pull them out from time to time when we get to something like this, where we harken back to an old lesson, and we want you guys to take a minute and review those. That way we're constantly reviewing as we're going along. Now, there's only 2 problems like numbers 9 and 10, and I didn't want to do one and only leave you with one to practice on. I wanted you to be able to have two different problems to practice on. So I went ahead and made up another problem. I know Ms. Blaylock has done this a couple times with you guys. That way we're not stealing any of the practice from you. We want to make sure that you get a good ample opportunity to demonstrate that you can do these problems before the mastery check. So this is a made up problem. It's not in your application. You might want to follow along on the back of your application next to those notes. Alright, but we're going to walk through one of these problems. Now, Guadalupe has a gift card to Little Caesars Pizza for $45. Hot and ready pizzas cost $5.35 with tax. If Guadalupe wants to throw a pizza party for her friends, we want to write and solve an inequality to model the situation, and then tell what possible amounts of pizza could she buy. Now, we know that the pizzas cost $5.35 with tax. We know she has $45. What we don't know is the number of pizzas. So the first thing I'm going to do is define my variable. I'm going to say that X is my number of pizzas. And you could use any letter. I like using X. I know Ms. Blaylock likes to use letters that start with what you're working with, so she would probably use a P for pizzas. Alright, I'm just going to go ahead and use X. It doesn't matter what letter you use as long as you're just using a variable. Alright, now, we know that she has $45. Now, we got to think about what she can spend. If she has $45, she's not going to be able to spend more than $45. Alright? She can spend exactly $45 and have no money left. Or she can spend less than $45 and have some extra money left, maybe if she wants to buy soda or chips later on. Alright, so since $45 is the most she can spend, we have to have less than or equal to $45. Now, we don't know the number of pizzas, but our cost of pizzas is $5.35 for every pizza that we have. So that would be multiplying 5.35 times X. Now, if we want to solve for this inequality, we treat it similar to our equations. We're going to divide both sides by 5.35. Alright, this will cancel and we'll have X is less than or equal to. And let's go ahead and pull up a calculator and go ahead and do 45 divided by 5.35. Give it a second as my calculator is opening up. There we go. 45 divided by 5.35, and we're going to get a big long decimal, 8.411214953271103. Alright, so I'm just going to round this a little bit, 8.41. Let's think about this answer though. If you go into a pizza shop, are you going to be able to tell them that you want 8.41 pizzas? You could, but chances are whoever's at that checkout register is probably going to laugh at you when you ask for 0.41 pizzas. Alright? They're not going to give you just 0.41 parts of a pizza because that's the extra money you have. So the only money or the only amount of pizza that we have enough for is that whole 8 pizzas. So we are going to round to 8 because we don't have enough money for a full 9, and they're going to laugh at you if you ask for 0.41 pieces or 0.41 parts of a pizza. Now, it does ask for what possible amounts of pizza she can buy. So this is our inequality, but we have a second follow-up question. What possible amounts of pizza could she buy? So it is a less than or equal to, so that means that she could buy 8 and she'd be using up pretty much all of her money. Alright? But she could also buy 7 pizzas because that is less than 8. She could buy 6 pizzas. She could buy 5, 4, 3, 2, 1. And really, if she wanted to be really stingy on her pizza party, she could buy 0 pizzas. Alright? But what we don't want to get to is negative numbers. She can't buy a negative amount of pizzas. You can't go to Little Caesars and say, I want -1 pizza. And that would basically mean that you were handing them a pizza, which they, again, would probably laugh at you. And we don't want Little Caesar people laughing at us, so let's stick with answers that make sense. So, we could buy any of those amounts of pizza. Alright, so that should be a good guide to help you on those 2 problems. Again, we didn't want to steal that practice from you. Go ahead and complete those problems, and if you have any questions, let us know. See you in the next video.